two ships leave a harbor together, traveling on courses that have an angle of 135 degrees 40 minutes. Okay, so they leave this harbor, and the angle between their courses is 135 degrees 40 minutes. If each travels 402 miles, how far apart are they? So we're wanting this distance here. Okay, so we just need to solve a triangle here. We've got two side lengths and an angle. So this could be the side-side angle case, or this could be the side angle side case. The side-side angle case, we'd have to use the ambiguous case of the law of sines, but this is the side angle side case where we can use the law of cosines. Okay, so let's use the law of cosines to get length x. Now there's three equations with the law of cosines. They each apply to, like, you pick an angle. There's only one angle involved in each equation. So we're going to use, but the three side lengths are involved in every equation. So we're going to use this angle. Okay, so we start by saying we take the square of the side length opposite the angle that we're using. Then we do the sum of the squares of the two adjacent side lengths. So 402 squared plus 402 squared, which is just 2 times 402 squared. Okay, then minus 2 times the product of the adjacent side lengths. So 402 times 402, that's going to be 402 squared. And then times cosine of the angle. So 135 degrees, 40 minutes. How many degrees is 40 minutes? So it's 2/3 of a degree. So 135 and 2/3 of a degree is equal to what? So 135 times 3, 405, plus 2, that's 407 thirds degrees. Okay, so now let's just solve for x. We see we can actually, this is a nice case where we can factor out this 2 times 402 squared, and we're left with 1 minus okay. So cosine times 402 squared times 2 is this. Take the square root of that, so about 745 miles apart. Okay, so that's the distance between the ships. Now we could continue on and get these angles here. It looks like they're going to be the same angle since this is an isosceles triangle, but we don't need to do that, so we're not going to do that. But we could if we wanted to. Now you would have to use the law of sines to do that, and there is a little bit of ambiguity there. It's not nearly as much as the ambiguous case of the law of sines, but there are a couple of things you need to be aware of if you're going to continue on. If you're solving a triangle with one of the law of cosines cases, and you're going to continue on to get the angles, because you start by getting a side length, and well, no, the side case you start by getting an angle, but there's no ambiguity. Make sure that there are a couple of things you need to know when trying to solve a full triangle using one of the law of cosines cases. So make sure it's not a big deal. You just need to be aware of it. So make sure you watch the textbook video or the example problem video. That's where we solve triangles in general. There's no like special application.